Hey guys, just wanted to follow up on our meeting that we had. So with that, the Bohr radius, I think what you guys had was something like this. Okay, so if you go through and do like the textbook does, like they do for the Bohr model, you come out with that our new radius is half of the original radius. And so that's totally correct, but you just, I think there's another little piece here. And so if you follow through with the procedure for doing this, so the next part is to look at the energy. And so we'll say the new energy. All right, so if you look at the particle, again, we're thinking classically because it's the Bohr model. So when you write this potential here, it's again, there's going to be this factor of 2. And so essentially, you've got to remember that there's a factor of 2 in the energy as well as the factor of 2 for the radius. And so the little trick that they often use is if we cancel out the r down there with the squared there and multiply all this business by 1/2, I get a little equation here for the kinetic energy. And so if I plug this in for the kinetic energy, I get k e squared over r minus this business. And so if I do this, I get negative k e squared over r for the new energy. And if I plug in our value of r, so this would be, again, I should have been probably calling this the new radius, get negative k e squared, and then down here I'll get n squared a naught, and with a 2 upstairs. And if you look at the original energy in the Bohr case, it's k e squared over 2 n squared a naught. And so basically, since this is divided by 2, this is times 2, this actually comes out to be 4 times, we should call this the Bohr energy. So I think just that another factor of the 2 in the energy is all you guys were missing. And then finally, just to kind of talk about this one again, because it is tricky. So we have these 2 pictures, and it's really hard to draw these, but let's sort of try to draw like this. So this is the one, so I'll call this E1, and this one I'll call E2. And so if you draw these, so basically the trick is if this guy has to sort of hit pretty close in order to come down like this. And I'm totally going to mess this up, drawing it upside down, but let's not think about this one too much. And so if you look here, so this guy, the wavelength kind of extends out pretty far. And so if you look here for the wavelength of case 1, where this one, because of the fact that it has to hit 0, right, it's going to be a little bit skinnier. And so if you can look at this, you can hopefully convince yourself that this one is going to have a longer wavelength, and so therefore E1 is going to have a smaller energy than E2. Okay, hope it helps, guys.